Hey, and welcome back to the Stormdancer channel. I've had a lot of the subscribers answering a poll about boat electrics and the rewire that I'm doing on Stormdancer. And I'm going to be doing things that are not necessarily in line with the code from your area. We're going to do it old school. If you want to put a couple of lights in your cabin and you need a switch, it's not tricky. You can go online and buy a panel like the one I'm showing here. But if you need a couple of panels, the fact that you've got a handful of switches, USB outlets, cigarette lighter and duplicated voltage meters seems a bit ridiculous. When it came to Stormdancer, I did a lot of thinking about what is it I actually want and how am I going to go about having what I want. And having built my own 3D printer some years ago, it seemed logical to me that I should develop a panel for Stormdancer and, with the viewers in mind, share the 3D print files, the STL files, on Thingiverse on the Stormdancer channel there for free. So what I've come up with, this 8-way switch, this 4-way with a blank area below, and a blanking panel. And then I also created files for these backing boxes, and that gives us, we can either join them or stack them. And with the different panel types that I created, I'm running out of hands here. All your switching needs, depending on what you want or how you want them. And all of the panels are interchangeable. So there'll be a link in the description below to the Stormdancer channel on Thingiverse. And also in the description below will be a link to Amazon for these 20 amp 12 volt circular switches that are a 20mm cutout. And that means if you want to follow along in this, you can either download the panels, print them, or you can take a piece of plywood and drill 20mm holes in it, or whatever you want to make your switch panel out of. And then I'm going to show you how we go about wiring them up. But before we get into it, a quick overview. When it comes to 12 volt wiring, you're starting off with a battery bank going to your bus bars, where you have a neutral bus bar and a positive bus bar, on which you can tap off instead of everything going back to the terminals on the battery. And one of the tricks that I'm using here to keep things simple is, instead of having a loom of cabling going up to these switches, I'm using multi-core. The multi-core in question is 12 volt DC design multi-core that's normally used for things like a trailer board on a trailer that's going to a power plug into the back of your car or your caravan. And they are 7-core. Now the cable that I'm using, this 7-core, is rated at 11 amps per core. These switches are rated at 20 amps. But that's worth bearing in mind, because if you are going to be drawing high power, you want to go through a relay. This is as simple as you want a few cabin lights that are LED, and you're dealing in milliamps and low current. We can actually power directly through these switches. And that's what I'm going to be showing you here, is how the switches work and how I prepare the back of these, which can give you a quick glance as to where the buses are. So let's get into it. This video, we have a lot of subscribers and asked specifically to cover boat electrics and a walkthrough. Many of you have an idea how to work with the 12 volt system or how to design a 12 volt system, and then we've got other viewers out there that don't even know where to start. So my choice for Stormdancer is to go with these 20 amp LED rocker switches. First of all, I want to explain for the absolute novices what's going on here. These two terminals, in essence, are, we need a diagram. Hold on. Okay, so if we take our 12 volt battery and give it two terminals. So far, I don't think we've lost anybody. So we have a minus on this side and a plus on this side. It can be either way. Because your boat doesn't have a ground earth in the chassis like a car would have, it means that absolutely everything has to reference back to your neutral over here, which is a bus bar. And our bus bar, it's a threaded holes in a metal bar that take screws into each hole, of which we can take off terminals. But it means that for every light, for everything that's working on 12 volts on your boat, you've got to bring your black cable back to tie into your negative side. Now on the positive side, we can go the same way. We can actually put in a positive bus. And before we get there, we can be doing with a fuse that's in line as a master breaker switch. Well, sorry, when I say a master breaker switch, a master fuse, and also a very poor representation of a master breaker switch. So basically you can turn the connection to the battery on and off from here. Complete isolation. What your switch is doing is, if you were to take two drawing pins, which is how you would learn this 20, 30 years ago in tech, two brass tacks, two drawing pins, and we bring a positive cable here and another cable off the far side of it. And from your brass tack, if you put just a little piece of metal bar across, when they touch, it forms the bridge. And that's what's happening in the switch. In your switch between here and here is the equivalent of two brass drawing pins with a metal bar pressing down on them. And in fact, what's inside of the switch is little more than a spade terminal. A spade terminal. Let me represent the bottom of the box on your rocker switch. And on here is like a drawbridge for want of visualizing it, with the spring under it. And as your rocker switch, next to a circular on top, has a spigot at the bottom that pushes this down. So when we click it, there's a little lever on the inside in plastic that's pushing the connector down onto the other pin. So really, all that's going on here with these switches is that these two terminals are acting like a bridge, foundation of a drawbridge. The reason I'm explaining it so simply is that for those of you who do not have the first clue about electrics, just for simplicity, to get you moving, think of this as being a lot like traffic. It's a very good analogy for the simplify it. So if we had, this is a road coming up here, and this is a lifting bridge. If you open the bridge, no traffic flow. Close the bridge, traffic flows. However, for traffic to flow, it needs a return, so that you've actually got your full circuit. So if our battery is here, you've got your plus, you've got your minus, you have this switch, which is a lifting bridge, and let's say up here is your grocery store or your lamp. So if you understand traffic flow, you're halfway there to understanding how a DC system works. We also have an LED light. So when the switch is closed, there's now power able to reach the light, but it's not going anywhere yet. Which means that needs to come back to the neutral. So if we have a lamp up here or whatever is working, we can flow to the lamp and come back down on the negative return. But the LED within the switch also needs a negative. So this is the interruption to your positive feed, and this is little more than the negative pin of the LED. Okay, so to simplify things, for Stormdancer, I have designed my own 3D printed panels. Part of my reasoning on this was I wanted a legend area for under each switch. Words of Blue Peter, here's one that I prepared earlier. So under each switch I wanted an area where I could print a sticky label to say what the switch is for. And then on the back of the switch we have a requirement here to put power to each of the switches, then an output to each of the devices those switches are feeding, and also we need to connect a rail along here to be the return feed for the LEDs. So we need a plus bus on the top, and we need a return bus on the bottom. This is 11 amp per strand multi-core, as used on trailers, caravans. One, two, three, four, five, six, seven. Okay, so I've got 7 cores. However, my intentions is to feed the 4 switches into one multi-core. Rather than using the type of terminals that you see here, which are the kind of thing that everybody has laying about because you'll trip over them in local supermarkets. I don't use them. I have them, but I don't use them. Instead, it is my preference to use actual brass, which is these guys. Come with their own silicone, soft silicone cover. I'm going to show how I make these up. I put a little kink in the end of the cable, not much. Okay. Again, I'm showing you how I do this. And there's a method in my madness. And yes, you can use the crimping tool. But as I say, too long in the tooth for this. And as you can see with this, you don't need to have a crimping tool. So I've closed this over with a pair of, well, except the grabber, but long with wires is intensively what you see. Then coming in back after with a shock collar, lead solder. So I now have a soldered terminal that will not pull out. I then pull up the silicone sleeve, cover it, and then behind the silicone sleeve, I bring in the heat shrink. Which means I have a silicone sleeve going onto a piece of heat shrink on the inside of it. I don't know if you can see that. Excuse my ignorance. Instead of using a heat gun. But I now have a soldered terminal. It's impossible to pull the cable out because it's soldered. So with the long pliers, closing in the back, clamping it down, and then forward pin, clamping forward, clamping it in. So we now have a soldered terminal. And I'm not French, so I don't say solder, okay? I'm in Northern Ireland. So, where does that get us to? When I have a multi-car coming single cable coming from the box, it's coming down to the negative feed for the LEDs, the twin cables going up to supply the rail in the box with the switches, and the switches coming back here that are able to go straight into the fuse panel. And I know some of you are getting lost in trying to understand what that means, but I'm about to demonstrate it to you. So we have 1, 2, 3, 4 power outs that are fused. We have only a need for continuity here, so basically any fuse. Doesn't matter if it's a 5 amp or 30 amp, it really is only a continuity for the neutral bus, and I'll show you for why. So I've brought in the little battery box, and if I connect in the plus and minus to here and pop in 2 fuses. Strangely, I don't have 2 fuses. No, I don't have any blade fuses here. That's annoying. Okay, well, for the purposes of demonstrating, I guess. Don't try this at home, folks. I'm just going to bridge these. If I come back and I have a switch tie, for example, this switch was the brake, I'm either able to move terminal across or I'm able to swap the switches around. This is the reason. Like, I load this up with blade fuses, and that is a plus feed from the distro. That's a neutral feed back to the distro, and then these are the 4 switched outs. This is the fuse panel. It gives me 1 row of 4 switches with a dedicated fuse panel, and I can do that for every row of 4. And it means that it's neat and tidy, that this is in the actual electrical box, and this can go anywhere in any room with a single cable operating 4 switches back into the box. Nice and simple. So, 12-volt feed into the fuse holder. I'm using the fuse holder as a transport bus across from the neutral up to the box, and 4 switch lights. 1 in, 4 out. This is only the feed for the return of the LEDs. Okay, so power in to 4 back out on the fuse board, and this just becomes a remote control unit for it. Simples. Until next time, stay safe, stay happy, and do not give up on your dreams.